All right, so the last thing we need to cover today is this theorem called the squeeze theorem, which is like the weirdest named theorem ever. And it is a theorem that makes a lot of sense. Just instinctually, it makes sense. But again, the notation is just crazy. So stick with me and stop me if you have a question. Okay, so here we go. If h of x is less than or equal to f of x, which is less than or equal to g of x. What that means is function f is squeezed in between functions h and g. So if that is true, and the limit is x approaches c, and again, c can be any number, for h of x equals some number L, like say that limit goes to 12 or 17 or 65, you know, whatever you have. And that is also equal to the limit as x goes to c for g of x. So if f is stuck in between these two, and both of those two have this limit L where they are heading, then the limit as x goes to c for f of x also equals L. That's the conclusion that you're allowed to make. So let me draw a picture of this, and I'll try to color code so that you can see what I mean. It makes a lot of sense. The notation just looks really weird. So say this is function g of x, and this is function h of x. And this is that value c, which can be any number. If both of those have that as their limit, whatever that L value is, and if f of x is squeezed in between them, then f of x also has to go to that L value, whatever that is. Does this make sense to everybody? If that one's squeezed in between, and the top one and the bottom one both go to this certain limit, then the one in between is going to have to go to that certain limit as well. It's smushed in between them. So that is the squeeze theorem. Here's how this can show up. Let me put a problem here. Do all the functions have, well, if you have a limit there and you have a, well, that is a really, really good question, Abby. No, I guess you could have a hole there. I guess they wouldn't have to be continuous. It wouldn't matter. It's just a limit. It's just behavior. So yeah, that's a really good point. No one's ever asked me that before. I guess you could have a hole there because they don't say anything about continuity here, just that the limits exist. They're all heading towards that value. It's just the behavior. So yeah, good point. That was a really good question. All right, so we're going to say h of x and g of x are continuous. Now, these functions are continuous for the purposes of this problem that we're going to do. And I think normally they would give you continuous functions. I should say it's the pain meds, making your brain real lucid. All right, if you have two functions that are continuous and h of 5 equals g of 5, which is 2. So we're saying those functions are continuous. That means they have a point, which is at 5, 2. And that means the limit would also have to be 5, 2. Those are all going to agree. All right, so since those functions are continuous, h of 5 equals g of 5 equals 2. And f of x is in between both of those. So that's all true. Here's your question. Is f of x continuous at x equals 5? That is your big question, okay? The answer is going to be yes. If f of x is squeezed in between these two and they're both continuous and they have a point at 5, 2, then f of x is also going to have a point at 5, 2. It's just quite a bit of writing to explain this. And again, it's not like a difficult concept, it's just a lot of notation. So here's what you would have to write. And you kind of need to view this as like essay writing here. I realize it's math class, but here we go. Since h of x and g of x are continuous, they have this point that's 5, 2. So since they're continuous, the limit as x goes to 5 for h of x and for g of x would also be 2. So if they have this 0.52, since they're continuous, they have the limit as x goes to 5 is also going to be 2. Because continuity means you have a point, you have a limit, they agree. They're going to both have to be 2. So since that's all true, and since f of x is stuck in between those, so since f of x is stuck in between those, limit as x goes to 5 of f of x has to also be 2. So we're allowed to make that conclusion. That's what the squeeze theorem tells us. So we've got there to be a limit. Now we need to prove that there is a point. All right, so also h of 5 is going to be smaller than f of 5 is going to be smaller than g of 5. I pretty much just rewrote this but put 5s in it. And both of these ones are equal to 2. So if both of those points are 2 and this one is stuck in between, then f of 5 also equals 2. So we said that there's a point, we said that there's a limit, they both equal 2. So therefore, yes, f of x is continuous at x equals 5.